to look at how to find real-life models that might possibly be polynomials. This is going to look very familiar from stuff that we've done before with lines and with quadratics. And it actually just requires us to go one step further than we have gone before. First of all, let's look at this table of data, and this could be from anything, but we have a series of x's and y's, x, -2, -1, 0, 2, and 3, and the corresponding y values are -25, -4, 3, 23, and 40. If I want to find an appropriate model for that data, the first thing I want to do is I want to get it in my calculator. So I'm going to go to Stat, press that button on my calculator, and in Stat I'm going to choose Edit. Now remember that once you've chosen Edit, your x values go in L1. Now, you know, if it's real life data, they're probably not going to say, this is your x value. They're probably not going to say, this is your y value. Your y's go in L2. What they're going to say is that at a certain time, the function has a certain value. Or when this is true, this is true. So your independent variable is always going to be your x. Your dependent variable is always going to be a y. So your x is going L1, your y is going L2. Once I've done that, I need to find an appropriate model. Now, sometimes we know what model we want, sometimes we don't. So how do we tell what we want and which one is the best? So I'm going to go to Stat, and then I'm going to go to Calc. Now, I want to know what my model is, what is the best possible model for this set of data. So I'm going to do several calculations. First of all, I'm going to do linear regression. So I'm going to make the choice LINREG and let it give me a model that is a linear model. The model it would give me for linear regression is y equals 11.93x plus 2.63. Perfectly good model, but it's a line, and is it the best model? Well, I don't know. So how are we going to tell? Well, we're going to write down this number r squared, which is also going to be on my calculator, and it's going to be 9.9772. We'll come back and talk about that in just a minute. All right, I'm going to leave my same set of data in there, and I'm going to find a quadratic model. So I'm going to do quadreg. Next one down on the calculator. Remember, I've got to go Stat, Calc, and then quadreg. And it's going to give me this model. It's going to say y equals -0.33x squared plus 12.29x plus 3.68. There's my quadratic model. Well, you know, that might be better. Is it better? Is it not better? Well, my r squared value here is 0.9785. That's going to tell me which one is the best model. We'll come back when we get done with the rest of our models here. Then I'm going to do cubic regression. So the next choice down is cubic regression. Still got all my data, Stat, Calc, cubic regression, and it gives me this nice long model. I'm going to round it off to 2 decimal places here. So 0.92x cubed minus 1.46x squared plus 7.98x plus 4.68. And you should be doing this at the same time I am, making sure you're getting the same model every time. So there's my model, and it gives me an r squared value of 0.9973. And then finally, I'm going to do quartic regression. And it gives me a model of y equals -0.33x to the 4th plus 1.67x cubed plus 0.33x squared plus 5.33x plus 3, and an r squared value of 1. All right, so if I was asked specifically to find a cubic model, this would be my answer. If I was asked to find a quadratic model, this would be my answer. But what if I was asked to find the best model? Which one of these is the best? Well, let's look at these R squared values. R squared tells you how well the data fits the model that you have found. The closer that value is to 1, the better the model. So look at these values, 0.9772, 0.9785. This 0.9785 is closer to 1 than this 0.9772. So the quadratic model is better than the linear regression model. 0.9973. This cubic model is better than both of those. And this one is equal to 1. That means that this quartic model that I found is a perfect model for that set of data. It is the best model. So if I wasn't told which type of model to find, that's the one I want to use because I'm looking for the closest I can get to R squared is equal to 1. I have found a good polynomial model for my data.